Welcome to All Farm.
Sugarcane production begins with the choice of cane varieties to be planted, based on local soil and climate conditions. Choosing the right varieties ensures productivity and resistance to disease. More than 600 varieties have been developed in Brazil. The use of fertilizers is limited because solid residues from sugarcane processing are used in the fields to offset traditional fertilizers. Filter cake, for example, rich in phosphorus, is recovered at the mill and utilized as an organic fertilizer. Residue samples are first analyzed in a lab to determine the volumes that can be applied. Once the exact contents are known, the residue is loaded onto trucks and carried to the fields. Sugarcane stalks, developed especially for use as seedlings, are scattered over the soil by planting machines. The seeds are actually clumps of sugarcane. As it's pulled by a tractor, the machine opens a groove, separates the clumps, and places them in the soil. On average, a cane field must be replanted every 6 years. Brazil is the world's largest sugarcane producer, responsible for 35% of global production. Cane fields cover about 8 million hectares, or about 20 million acres, or 2.5% of the country's arable land. Another residue of sugarcane processing is known as vinasse. Its contents are rich in potassium and other nutrients. Canal systems are often used to carry the vinasse to various points in a cane field. Applying vinasse as an organic fertilizer is a process known as fertirrigation. The practice is tightly regulated by environmental authorities. It reduces the use of petroleum-based fertilizers, which cuts down emissions that contribute to the greenhouse effect. Biological techniques are also widely used in cane fields. Natural enemies are introduced to fight pests and disease, further reducing the use of industrialized chemicals. Close to 90% of Brazil's sugarcane crop is located in the south-central region, where the annual harvest takes place from April to December, coinciding with the dry season. Harvesting at that time of the year allows the cane to reach full maturity with optimized sucrose yields. Mechanization is expanding rapidly and already accounts for more than 55% of the harvest in Brazil's top cane-producing state, São Paulo. Mechanized harvesting eliminates the need to burn the sugarcane straw, an essential step for manual cane cutting. The straw is now separated from the cane by the machine and left on the ground as mulch. It also protects the soil against erosion. The cane is chopped and deposited in a vehicle that moves alongside the harvester. A single machine can harvest up to 800 tons of cane per day. In a growing number of mills, part of the straw is removed from the field and used to generate bioelectricity. In the future, the straw will also be utilized to produce second-generation or cellulosic biofuels. At the end of the day, the harvested cane is transferred to a larger vehicle to be transported to the mill for processing. Manual harvesting is carried out by agricultural field workers. Stretching exercises are a common warm-up practice before work begins. The straw is burned before manual cutting under strict environmental regulations. The burn drives away snakes and other potentially poisonous animals and makes it easier for workers to get to and cut the cane, now without its dense foliage. Machetes are used to cut the cane stalks always close to the ground, where sugar juices are richer. An agreement signed between the São Paulo state government and the sugarcane industry will put an end to manual harvesting in the state by 2017. Once it's cut, Sugarcane is highly perishable and needs to be processed in a mill as soon as possible to avoid losing its sugar content. Most cane is delivered to a mill less than 24 hours after harvesting. At the mill, once the truck is weighed, a sample of cane is removed and analyzed in the lab. The sucrose content in the cane determines how the industrial process will be carried out. August and September are key months for the harvest in south-central Brazil, when sucrose levels can reach 150 kilos per ton of sugarcane. After the truck is weighed and the testing concluded, processing begins. The cargo is transferred to conveyor belts that carry the cane to the crushing system. Cane that was cut manually is first washed to remove impurities. The water is treated and reutilized. The cane is then chopped up and readied for crushing. Sugarcane harvested by machines is cut into small pieces by the harvester and skips this phase. After the crush, either by rollers or a diffusion system, what's left of the cane stalk is known as bagasse, a fibrous residue that is burned in boilers to generate bioelectricity. The cane juice is used to produce sugar and ethanol. The projected cane crush for the 2010-2011 harvest in south-central Brazil is expected to reach 595 million tons. The juice that results from the cane crush is used to produce sugar and ethanol. Most of Brazil's 430 active mills can produce both. How much of each product is made varies according to market conditions and technical aspects of the mill's design. Juice from the first and second crushes is richer in sucrose and is usually dedicated to sugar production. The first step is to purify the juice, which then undergoes an evaporation and boiling procedure. At this stage, the sucrose is already crystallized. The crystals are isolated in a centrifuge from molasses, which can later be fermented to produce ethanol. The crystals are moved to dryers and then filtered and stored. In all, the process from the arrival of the cane at the mill to the storage of sugar takes 15 hours. Each ton of cane produces about 120 kilos of sugar. The finished product is packaged for shipment to stores and supermarkets. Sugar types for industrial applications are placed in special containers for large-scale shipping. The storage process for all types of sugar produced in Brazilian mills is supervised by the National Health Inspection Agency, known as Anvisa. Brazil is the world's largest sugar producer and exporter. It answers for about 20% of world production and 40% of global sales. Ethanol is produced from sugarcane juice through a fermentation and distilling process. The juice is first purified by various filtering processes until it is ready to be fermented and mixed with yeast. At this stage, the liquid is called fermented wine. The alcohol contained in the wine is recovered in distillation and rectification columns. Hydrous ethanol, the type used in flex fuel vehicles in Brazil, is produced at this point. To obtain anhydrous ethanol, the type that's mixed with gasoline, the liquid undergoes an additional water removal or dehydration stage. The entire procedure from the arrival of the cane at the mill to the finished product takes 15 hours. 1 ton of sugarcane yields about 85 liters of ethanol. Brazil produces more than 30% of the world's ethanol. It is the top exporter and second largest producer of the biofuel, behind the United States. In the 2010-2011 harvest, production is expected to reach almost 30 billion liters. Ethanol produced in Brazil follows strict technical specifications and international standards. Once it's ready, ethanol is kept in large storage tanks until it's sold. More than 90% of the country's storage capacity belongs to sugarcane processing mills. About 80% of Brazil's ethanol is consumed domestically. Although Brazil is the world's largest ethanol exporter, the global market is still limited and highly volatile. Top international destinations for Brazilian ethanol are the United States and the European Union. Several transportation methods are used to distribute ethanol inside Brazil, from railways to riverboats and barges to pipelines. But the most common way to transport ethanol is by truck. There are more than 500 distribution terminals throughout the country. Today, all vehicles on the road in Brazil use ethanol in some way. Those equipped with flex fuel engines use pure hydrated ethanol, while gasoline-powered vehicles use anhydrous ethanol, which is blended with all gasoline sold in the country. Flex fuel cars, introduced in 2003, account for over 90% of new light vehicle sales. Of all vehicles on the road in Brazil in early 2010, 40% are flex. A significant milestone was reached by Brazil's automotive industry in March of 2010, when the 10 millionth flex car was built. Bagasse is the fibrous residue that's left after sugarcane is crushed. 1 ton of cane produces about 250 kilos of bagasse, which accumulates quickly. Large dunes of bagasse are a typical feature of Brazilian cane processing mills. A system of conveyor belts transfers the bagasse from its storage area to boilers, which produce vapor. The vapor powers turbines that generate renewable electricity, or bioelectricity. Control centers equipped with the latest technology monitored the electricity produced, utilized, or exported by the mill to national distribution grids. All Brazilian mills are self-sufficient in energy, producing more than enough electricity to cover their own needs. A growing number of mills is generating a surplus, which is sold to power companies and helps to light up numerous cities throughout Brazil. In the near future, bagasse is also seen as an ideal raw material to produce second-generation or cellulosic biofuels. The expanding use of bioelectricity, combined with the wide-scale use of ethanol, explain why sugarcane is already the second largest source on the Brazilian energy matrix, which is considered the cleanest in the world. In early 2010, about 2,000 average megawatts, or 3% of Brazil's electricity needs, were being supplied by sugarcane-based bioelectricity. That total could reach 13,000 average megawatts by 2021 if all potential sources are fully developed. That would be enough to cover the needs of entire countries like Sweden or Argentina.